Good evening. So last class we were continuing the MCQs. So this one class also will continue with the MCQs. Next chapter. So today we are going to complete haloalkanes and haloarenes. So which chapter you want next? Which chapter I should take next? Yes. Which chapter do you want me to take next after completing haloalkanes and haloarenes?
D and F block elements.
Okay, fine. I'll take D and F block elements. Okay. So we'll continue with the MCQs. Everybody has come. Yes, there are 7 students. Okay, we'll continue. So this is a question in a SN2 substitution reaction of the type. So RBr is a alkyl halide plus Cl minus. So Cl minus is the nucleophile in the presence of DMF. Okay, it gives you RCl plus Br minus. So this is a SN2 mechanism. You know SN2 mechanism, it is a one-step mechanism, right? So what does SN2 mechanism? It goes via a transition step. Okay, so their attack and attack of the nucleophile and leaving of the leaving group. Okay, so attack of the nucleophile and the leaving group will leave at the same time via a transition state. Now here in this, which of the following has the highest relative rate? So these are the 4 options. So whenever we are talking about SN2 mechanism, so what is the rate of reaction? So the rate of reaction, it depends upon the concentration of substrate as well as the nucleophile. Okay, so here the rate of the reaction depends. Why it is bimolecular? Because the rate depends on both the substrate as well as the nucleophile. Now here in SN2 mechanism, how the rate of the reaction, it depends on what? It depends upon the stability of the carbocation. Now here, how is the stability given? Primary is greater than secondary is greater than tertiary, right? So methyl cation is greater than primary, then secondary, and then tertiary. So now you have to see the following options in this. You have to see what you have to see. So you know that the attack should take place. So if I consider this is as an alkyl group, so the attack of the nucleophile, okay, the attack of the nucleophile will take place from the rare carbon. So what are the things you have to see? See that across this alkyl groups, there should be no much crowd. Okay, there should no much crowd so that there will be no steric hindrance. You have to see that there is no steric hindrance. Okay, there is no steric hindrance. So because of that, this order of reactivity, it will be following. So just see the options and tell me which option. Yes, Komal has told it as B. What about others? Okay, if I consider the option number 1, okay, if I take option number 1, so what will happen? The attack will takes place at this particular carbon. Okay, so if you take as Cl minus, so there is what? It is Cl minus. So if the Cl minus, if it attacks from the rare carbon, so can it attack here? Because there is bulkier CH3 group. Okay, and this should attack where? It will attack on this particular carbon, and then the Br minus will leave, and here the carbocation formation will take place. So option A will be discarded. Why? Because there are 3 bulkier methyl group. Okay, so there is steric hindrance. So the attack will take place because there will be steric hindrance. So attack does not take place. So next is what? If I take option number this, okay, B, option number B. So here Cl minus will attack which carbon? This carbon, right? So only one methyl group is present. Only one methyl group, and the carbocation will be formed at this particular carbon. Okay, so this is stable. The relative rate is little, so we can consider this option. Okay, we'll see others also. Now, when we see the third option, so attack of Cl minus, where it will take from the rare carbon at this particular carbon. So there are still 2 bulkier group present here. Okay, so the relative rate is little less here. So this is also discarded. Then when we are talking about the fourth option, So the Cl minus, okay, the attack will takes place from the rare carbon on this carbon, and here the carbocation formation takes place, and there are presence of two bulkier methyl groups. So again, there is steric hindrance, so this is also discarded. So option B will be the right answer. Okay, option B will be right answer, as well as the formation of carbocation here, it results into a primary carbon. Okay, it results into a primary methyl carbocation. So primary carbocation. So primary carbocation is always much stable, okay, then secondary and tertiary formation, because in secondary tertiary there will be presence of steric hindrance. Okay, because the presence of bulkier group, it will make the relative rate will be decreased. So option B is the right answer. So you have to remember the factors, okay, influencing the SN2 mechanism. So we'll go for the next question. So if there is no rotation of plane polarized light by a compound in a specific solvent through though to be chiral, it may mean that A, the compound is certainly meso, B, there is no compound in the solvent, C, the compound may be a racemic mixture, D, the compound is certainly a chiral. So what they are saying, if there is no, if you have passed, so what is optically active when you say, so if you pass the plane polarized light, okay, if you pass a plane polarized light through a solvent, okay, through a solvent, okay, through a substance containing the, with a compound with a specific solvent, and what will happen, this plane of polarized is made to travel in one particular direction. Now this particular, what is happening, if there is no rotation of plane polarized when you are passing the light through a substance, okay, of a specific solvent, okay, then there is no they are saying that is there is no change in plane polarized light. Then what type of compound it is, whether the compound is meso compound, whether the compound is there is no compound in the solvent, the compound, it may be racemic mixture, and D, the compound is certainly a chiral. What it may be the option? Komal is saying option C. What about others? Yes. So chiral center means what? Chiral sentence means it will be when you're talking about chiral center. So chiral center means it will have a optically active. So they will have four different groups. Four different groups means what? If so, if you put a mirror, so the mirror image will not be superimposable. So if the mirror image is not superimposable, then they are what? They will be optically inactive. So this is wrong. The compound may be a racemic mixture. Racemic mixture means what? They will have D and L form. Okay, racemic mixture. Then when you're talking about so there the compound may be racemic mixture means what? Racemic mixture means they will have D and L form. Then this plane of polarized light, either it will be reflected to right hand side or left hand side. No, this is also wrong, because they are saying that there is no rotation in plane of polarized light. If there is a racemic mixture, then the plane of polarized will be rotated to either the right side for D form and to left hand side for the L form. So this is also wrong. There is no compound in the solvent. Okay, so this is also wrong. So without compound, the plane of polarized light will not travel. Then the first one, the compound is certainly a meso compound. Meso compound means what? Meso compound means half. Okay, there will be presence of a plane of symmetry. So half of the compound will be cancelled by the other half. So so if you have a meso compound, then the plane of polarized light will not be changed. Okay, though to be chiral, if it is chiral also, if it is a chiral also, but due to the plane of polarized light, what will happen? There will be no rotation. So option A is the right. So whenever you have meso compounds, okay, whenever you have meso compounds, then the plane of polarized light, that is PPL, that is if you pass the light through the compound, okay, the plane of polarized light will not change. Okay, there will be no rotation of plane polarized light if you pass it through a meso compound. So option A is the right answer. Okay, so next question, CH3 CHCl CH2 CH3 has a chiral center. Which one of the following represents its R configuration? So these are the four options. Okay, so whenever, so I'll write the compound. We'll see first, we'll check whether it has a chiral center. What do you mean by chiral center? Chiral center means to the carbon, okay, to the specific carbon, all the atoms, four atoms attached will be what? They will be different, okay? CH2, CH3. So you can see here, is it a chiral center? Is this carbon a chiral center? Yes, because the four groups which are attached to this carbon are different. Now what we have to write? We have to tell which of the following represents its R configuration, okay? Now, whenever you are writing the Fisher projection, now the priority will give the priority first. So priority first will come to the chlorine. Okay, first will come to chlorine, the priority. Second, we can give the priority to this ethyl group. CH2, CH3 is the ethyl group. Second priority goes to ethyl group. Then the next priority goes to the methyl group. So how does you give the priority? Priority is based on the number of atomic weight. Okay, atomic weight of the atoms. Okay, when you calculate, chlorine will be 35.5. Okay, CH2, CH3. So calculate this. This will be lesser than the chlorine, next to chlorine. Then will come your methyl group. Then will come your H group, a hydrogen. Okay, so priority is given based upon the atomic weight or atomic mass. Okay, so priority you can write. Then always the priority. Okay, the first two. So you can arrange the based upon the priority. So I'll write the Fisher projection. So Fisher projection, I'll write a straight line. Okay. Now here, the first priority will be for Cl. So I'll write Cl here. Okay. Then second will come here. So it will go in clockwise direction. Okay. So second will be C2H5 here. Then the third will be for methyl group. And the fourth will be for hydrogen. So the priority will be 1. Okay, 1. Then this will be 2. And this is 3. So when it goes in the anti-clockwise direction, then it is said to be a R configuration. So option here, which is the correct option? C, H3, right? So it is B. So B is the correct answer. So you can see that B is the correct answer. So B is the correct answer. So always you have to follow the priority list. So this is the correct answer. So this is 1, 2, 3. And when it goes in clockwise direction, so this is the R configuration. So when it goes in anti-clockwise, so when you arrange the atoms and when it goes in anti-clockwise direction, then it will be S configuration. Okay. So this is the answer. Which of the following is not a chiral? Which of the following is not chiral? Yes, which of the following is not chiral? You have to see which of the following is not chiral. So there are 4 options. Which will be the right answer? Just check. A, 2-hydroxypropanoic acid. B, 2-butanol. C, 2,3-dibromopentane. D, 3-bromopentane. For a molecule to be chiral, they should have all the 4 atoms attached to that carbon should be different. Okay. So they are saying which among the following is not chiral. Not chiral means what? They do not have all the atoms or all the groups same. Komal is saying option D. What about others? Anvita is saying C. Others? Not chiral means all the atoms are not the same. Okay. Any 2 atoms will be similar. So they are said to be chiral, achiral, not achiral. Okay. And chiral means what? All the atoms attached to that particular carbon will be different. X, Y, Z. Okay. Like this. So just say which answer do you think? Okay, Priyanka is saying option A. What about others? So I'll write the structures. So I'll write the structure first for 3-hydroxypropanoic acid. Okay, 3-hydroxypropanoic acid. CH3 2-hydroxy. So propanoic acid means 3 carbons, 1, 2, 3. Propanoic means OH. Okay, add 2, this is OH. So is it having 4 different atoms? Okay, you can see this is H. So is it having 4 different atoms group attached? Yes. So it is having a chiral center. So this is a chiral. This is chiral. Okay. So option A is chiral. So this is not. Then we'll go for the next one. Now next one is what? 2-butanol. 2-butanol. Okay. So butanol means 4 carbon. 1, 2, 3, and 4. 2-butanol means add 2 OH will come. Okay. 2-butanol. So CH3, CH, CH2, CH3. So is it a chiral? So I'll write it more simpler. H, H. So this is also, so 4 different atoms are attached. Yes, 4 different atoms. 1, 2, 3, and this is 4. So this is also a chiral. This is also a chiral. Okay, so chiral compound. So this is also chiral. Now we'll go for the next one. Next one is 2,3-dibromopentane. Okay, 2, 3. So add 2, 3. So 1 propentane means 1, 2, 3, 4, 5. So 2, 3. 1, 2. I can write here one bromo, and at third position here one bromo. The rest all CH3, CH2. Then here one CH. Then here one CH, and this is CH3. So check for the chiral centers. So this is 1. This is 2, this is 3, this is 4th group. Okay, so this is chiral. Then if I take, now if I take this particular carbon, then just see. So this is 1, this is 4th one. Okay, now if I take this particular carbon, if I consider this 1, 2, then this is 3, and this is 4. Okay, so this is also a chiral. So there are 2 chiral centers. So this is also chiral. Now we'll write the 4th one. Okay, now we'll write the 4th one. D option. So D option is pentane again. 1, 2, 3, 4, 5. So 3 bromo. So 3 bromo pentane. Okay, so CH3, CH2, then this will be CH, CH2, and this is CH3. So are the atoms similar? All the groups are similar. So this is 1 and this is 1. So these two are same, right? So 1, you can say this is same, this is same, this is different. So this is a chiral. So answer is D. Okay, answer is D. So all the atoms are not same. So it is not chiral. The option is D. Okay. So Komal has answered it right. Okay. So we'll go for the next one. Understood? So not chiral means what? All the atoms which are attached to the carbon will be not, they won't be different. Okay. Any two will be similar. So chiral means all the atoms attached will be different. So the other 3 options, the atoms attached or the groups attached are all different. So they are all chiral. So they have a chiral centers. Okay. So option 4. So 2 of the groups are similar. So it is not chiral. So option D is the right answer. So we'll go for the next one. Which of the following undergoes nucleophilic substitution exclusively by SN1 mechanism? What do you mean by SN1 mechanism? SN1 mechanism means what? SN1, it is a unimolecular reaction. Okay, it is a unimolecular reaction. Then SN1 is a unimolecular reaction. Then it goes via 2 steps. So first step is a slow step where there is formation of carbocation. Okay, and second step, then the attack of the nucleophile takes place and it is a fast step. Then the rate of the reaction depends upon the concentration of only substrate. Okay, rate of the reaction depends only on the concentration of substrate. Then the stability of carbocation, the rate of the reaction depends upon the stability of the carbocation. That is tertiary is more stable than secondary and the primary. So which among the following will go exclusively nucleophilic substitution very faster? Okay. Yes. Komal is saying option D. What about others? Yes. Others also have to answer it. Yes. How will I come to know whether you have understood or no? So ethyl chloride. So ethyl chloride is what? C2H5Cl. Okay, ethyl chloride. So ethyl chloride, or you can write CH3, CH2Cl. So this is a primary this. So you know that tertiary are more stable, right? So this is wrong. Then isopropyl chloride. Isopropyl chloride is what? Isopropyl. Okay, isopropyl chloride. So isopropyl chloride, you can say CH. Okay, so this is isopropyl chloride. Then next is what? Next is chlorobenzene. So this is chlorobenzene. Benzyl chloride is what? CH2Cl. Now at least you can say, seeing the options, seeing the structures, at least you can come to know which will undergo one. This is second, this is third, this is fourth. The answer is D. Okay. Why? In benzyl chloride, what will happen? The carbocation formed, okay, during the SN1 mechanism is resonance stabilized, because there is a presence of benzene ring. The carbocation which is stabilized, the benzyl carbocation which is stabilized will be resonance stabilized. So benzyl chloride will undergo nucleophilic substitution exclusively. Okay. So it is D. So out of these four structures, if you consider benzyl chloride, so the carbocation which will be formed will be resonance stabilized. So because of that, D, okay, that is benzyl chloride, it will undergo SN1 mechanism at a faster rate as compared to other three structures. Okay. So we'll go for the next one. So relatively, reactivity order of halides for dehydrohalogenation is. What is the reactivity order of dehydrohalogenation? So when you see the halogens come in group 17. How is the size increasing? Fluorine, chlorine, bromine, iodine. Okay. So you know the rate of the reaction. So as you go down the group, what will happen to the size? The size will increase, the rate of the reaction also increases. Okay, as bigger the size of the atom will be, the more stronger, or the more stronger is the reactivity towards the reaction. Okay, so when you're talking about the reactivity of order, so ri will be stronger as compared to rbr, as compared to rcl, and as compared to rf. So which is our option? Option B. Okay, option B is the right answer. So when you're talking about reactivity, so as you know, as you go down the group, what will happen? What will happen as you go down the group? The number of shell increases. As the number of shell increases, size increases, so the atom will be more stronger. So the bond between the alkyl halides will be more stronger. So it will hold the alkyl group more stronger. So because of that, halide in halides, Ri will be greater, the reactivity of Ri will be greater, then Br, then Cl, and then Rf. Okay, so this is the reactivity of halides towards the dehydrohalogenation. What do you mean by dehydrohalogenation? In dehydrohalogenation, what is getting eliminated in dehydrohalogenation? Dehydro means one hydrogen, halogen is Br, any halogen, or you can write is, and in general HX. Okay, so dehydrohalogenation means with the elimination of HX, that is one hydrogen and one halide group. So that is dehydrohalogenation. Okay, it is dehydrohalogenation. So option B is the right answer. Understood? So dehydrohalogenation means there will be elimination of hydrogen and one halogen group. So that is option number B. Next question. So this is a reaction. You have to tell. So you have to follow the steps which are written on the arrow, and you have to tell what is Z. Okay, what is Z in the above sequence reaction. So we'll try to write this reaction. So the reaction goes like this: CH3, CH2Cl in the presence of NaCN. So in the presence of NaCN, what will happen now? So there will be just a substitution reaction. So this product will be there. So and it forms CH3, CH2, CN. Okay. And NaCl, Na will combine with Cl and you get CH3, CH2, CN. Now further, it reacts with what? So this is our X product. So this reacts with nickel in the presence of hydrogen. So this is the what you are doing. You are doing addition of hydrogen is taking place. Okay, addition of hydrogen is taking place. Uh, okay, and so now what will happen? So this is a cyanide. Okay, there is C triple bond N bond. What is there here? Just see CN. How the CN will be there? CH3, CH, 2 C triple bond N. So what will happen? The addition of hydrogen will take place at this triple bond. So what will happen now? CH3, okay, then CH2, then the addition of CH2 here and here NH2. Okay, so across the triple bond, you are adding hydrogens. So CH2, NH2. Understood? So this is our Y. This is our Y. So further, we are going to add what? We are going to add acetic anhydride. We are going to add what? We are going to add acetic anhydride. What is acetic anhydride? AC2O. How is the structure of AC2O? CH3, C double bond O. Okay, O, then C double bond O, CH3. So this is the structure of acetic anhydride. Okay, CH3. So this is the structure of acetic anhydride. So now you are going to add acetic anhydride. So what will happen to this structure? Just see to the structure now. So acetic anhydride. So here CH3, CH2, CH2, NH2 is there. Now across this NH2, what will be added? Now here what you are adding? See, I'll write the structure here. CH3, C double bond O, O, C double bond O, CH3. Okay. Now OCH3. Now this OCH3 will combine with here and you will get here CH3, CH2, CH2. Okay, CH3, CH2, CH2, NH. Okay, NH, NH, C double bond O, CH3. So this is the product you are going to get. Plus what? One more mole is there, CH3, COO. Okay, this CH3, COO. CH3, COO will so this is getting combined. Okay, this will get combined and this will get combined with your H. So this will become CH3, C double bond O, OH. Understood? So these are the products. So what is our option? Z, CH3, CH2, CH2, NH, CO, CH3. So option number A. Okay, so option number A is the answer. So what we are doing here, just here, I'll show. So our first step is clear. Just here, first step is clear here. CH3, CH2, Cl. What will happen? We are adding what? NaCN. So Na will combine with Cl and Cl will be replaced by Cn. So you get CH3, CH2, Cn. Okay, between C and N, there will be triple bond. So what is nickel doing? So it is a okay, hydrogenation reaction. You are going to add hydrogen across this triple bond. So here two hydrogens are added. Here two hydrogens are added. Okay, and here two hydrogens are added. So what you get? CH3, CH2, CH2, NH2. This is your Y. Now acetic anhydride. I'll show this step again here. So acetic anhydride. So this react with CH3, C double bond O, O, C double bond O, CH3. Now what will happen? So here hydrogen. So NH and here one H. Okay, I'll write it here H. So what will happen just here? So this will combine. So CH2OH, okay, will combine here with this, and the other part H will be combined with this, like this. So what you get now right there, CH3, CH2, CH2, and H. Then C double bond O, CH3 plus CH3, C double bond O, OH. Understood? So like this, we are going to get the answer. Understood, right? So this way you have to follow the steps. So option A is the right answer. So we'll go for the next one. I hope is it clear? Yes. So the next question, a compound of molecular formula C7H18, H16 shows optical isomerism. Compound will be. Okay, so they have given a compound that is with a molecular formula. What is the molecular formula? It is C7H16. C7H16. Okay, so C7H16 is nothing but it is an alkane. Okay, it is an alkane. So what do you mean by optical isomer? Optical isomer means it should have a chiral center. Okay, optical isomer means it should have a chiral center. It should have a chiral center. So what I'll do, I'll try to write the structures first and we'll see which among the following compound will show a optical isomer. 2,3-dimethyl pentane. Okay, 2,3-dimethyl pentane means pentane. So 1, 2, 3, 4, 5. 2, 3. At 2 and 3 position, methyl groups are there. So CH3, CH3. So this is CH3, 2,3-dimethyl pentane. So CH, CH, CH2, CH3. Now you see whether it is optically active, whether it has a chiral center, dimethyl. Okay, so you can see this is one H group, this is one H group. So here H, so this is not a chiral center, wrong. Then here one H group is there. So here one H group, here one H group. Okay, now here you see whether it has a chiral center. So this is attached to one group. This is second, this is third, and this is fourth. So this is a chiral center. Okay, this is a chiral center. So it has a one chiral center is present. So this is optical active. Okay, our answer one is correct. So it is a optical active. Now we'll see, we'll check others option also. 2,2-dimethyl butane. Butane means 1, 2, 3, 4. 2, 2. So 2, here one CH3, here one CH3. 2, 2, right? So here one CH3, this is H, this is H, this is CH3. So one group, two group. So, and this is third one, this is fourth one. So these are similar. So this is not optically active, wrong. Then this is also not optically active. This is also wrong. So this is not optically active. So option B is wrong. Then option C will see 2-methylhexane. 2-methylhexane means 1, 2, 3, 4, 5. Okay, and 6. 2-methyl. So here it will be CH3. Then this will be CH3. This is CH, CH2, 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 and CH3. So this is also one carbon, two carbon. So these are similar. Okay, so this is not a chiral center. So this is also wrong. So our option A is the right answer because all the groups here you can see they are different, right? So you can see this is one group. This is one group. This is second group. This is third group. Okay, and this is fourth group. So all the atoms attached to this center, carbon center, are different. So it is option number A. Understood? Understood the option, MCQ still here? Yes, others? Okay. So it is A. Understood? So it is still A. So A is the answer. So you have to, you know what is optically active? Optically active means they should have a chiral center. What do you mean by chiral center? All the atoms attached should be different. So we'll go for the next question. The alkyl halide is converted into an alcohol. Alkyl halide means what? Rx. So Rx is converted into alcohol. How you can convert Rx into alcohol? So you can convert it by a addition of any nucleophile. Suppose there is a base. Okay, suppose there is a base. So the base can attack from either from the front or can attack from behind. So what type of reaction it can go? It can undergo a nucleophilic substitution reaction. So it can proceed via SN1 mechanism or SN2 mechanism. So what type of reaction it will undergo? It will undergo elimination or dehydrohalogenation, addition or substitution reaction. When you want to convert alkyl halide into alkyl alcohol, yes. What type of reaction it will undergo? Okay, Anvita Komal is saying option D. Yes, option D is the right answer. So it will undergo a substitution reaction. Okay, because if Rx is a primary, then it will undergo a SN2 mechanism. So you know, rate depends upon the concentration of two, and that is concentration of substrate as well as the nucleophile. When you are talking about SN1 mechanism, then it is the reactivity depends on the carbocation stability. So tertiary will be more stronger than secondary and primary. So the rate of the reaction depends only on the concentration of the substrate. So here it undergoes via a substitution reaction. So in the presence of base, so alkyl halide can be converted into alcohol via substitution. Understood? So next question. The following reaction is described as. Okay, so there are four options: A SN2, B SNO, C Se2, and D SN1. So which type of reaction? You see the reaction and you can tell me what type of reaction it is. You have studied SN1 reaction, SN2 reaction. Yes. Anvita is saying D, Priyanka is saying A. What is SN1 reaction? What is SN2 reaction? What are the reaction conditions? Just see the product as well as the reactant. See what is changing. You know what is SN1 reaction, what is SN2 reaction. Okay, what are the changes occurring? So everything. You can see that here. Okay, you can see what is happening here. Here, you can see here leaving group is here, and here what is happening? It is here OH, right? You can see there is a change in configuration. This is here your leaving group is present here. Here your attacking group is present here. When you can see such configuration, in what condition? When you have what type of condition? This is what it is, a type of nucleophilic substitution reaction, because your Br is leaving and your OH minus is getting attached. So this is a nucleophilic substitution reaction. Can you see an inversion there? Can you see inversion? Change in configuration is there, right? There is a change in configuration. So you can see that the nucleophile has attacked from the behind, right? The nucleophile has attacked from behind. So what type of reaction it is? So inversion of configuration is taking place. So you can see there is a optical inversion. So it is a SN2 mechanism. Okay, it is a SN2 mechanism. So whenever you can see there is inversion of configuration, that means it is undergoing a SN2 mechanism. Understood? So you have to check that. The configuration is very important. So next question. Reaction of tertiary butyl bromide with sodium methoxide produces. Okay. So what is the structure of tertiary butyl bromide? So this is tertiary butyl bromide. Okay. So this is tertiary butyl bromide. So this tertiary butyl bromide, it reacts with what? Sodium methoxide. So this is methoxide. So this is sodium methoxide. So it produces what? What does it produces? So what it produces? So sodium methoxide, it is a strong base. Okay. So first the reaction, it takes place what? There is a formation of carbocation takes place. So there is a formation of carbocation take place. So this Na will attach Br and this will be as CH3O minus. So this CH3O minus is a strong base. So what does it does? It will, this strong base, what it will do, this strong base will, it is also, okay, it is a, you can see it is having a negative charge. So, and this is a carbocation. So this strong base, it will abstract a hydrogen from here. Okay, it will abstract a hydrogen from this particular carbon and it will undergo what you say, it will undergo rearrangement. Okay, so the reaction, the product you obtain will be CH3 and CH2. Okay, plus CH3OH. So this is the option. So this is the answer. So what will happen, as the methoxy group is a strong base, it will abstract a hydrogen. So it will undergo a beta elimination. It will undergo a beta elimination. So that so this will abstract this hydrogen. Okay, and it will undergo rearrangement to form a double bond. So this is a product. So the product name is D. Okay, it is isobutylene. This is isobutylene. Okay, the name is isobutylene. So the name is isobutylene because it is having a double bond. Okay, so it is ene. So it is isobutylene. Understood? So option D. So this methoxy group, as it is a strong base, it wants to abstract the hydrogen from here. Okay, and it will undergo a rearrangement to give you isobutylene. So option D is the answer. Okay, I hope is it clear? So next question, Grignard reagent is prepared by the reaction between. How does Grignard reagent is prepared? What is Grignard reagent? RMGX. Okay, RMGS is Grignard reagent. So Grignard reagent here, this will be negative and this will be positive part. Okay, this will be positive part and this will be a negative part. So what is Grignard reagent? Grignard reagent, they are called as organometallic compounds. Okay, they are called as what? So they are called as organometallic compounds, right? Grignard reagents. So here Grignard reagents, how they are prepared? So it is a reaction between between magnesium and alkane, B magnesium and aromatic hydrocarbon, C zinc and alkyl halide, D magnesium and alkyl halide. So RMGX, so I can give you example as CH3 MgBr. Okay, so CH3 will have a minus sign and this complete will have a positive sign. Okay, see, Mg will have a positive sign here. So I will not write bracket, it won't look good. So it will be Mg will have a positive sign. Okay, so CH3 will have a negative sign. Now, when you are talking about magnesium and alkane, so this is magnesium. Is it a alkane? This group? No. So option A is wrong. Then second is magnesium and aromatic hydrocarbon. So magnesium is present. Is there any aromatic carbon here? Hydrocarbon? No. So option B is also wrong. Okay. Then C is zinc and alkyl halide. Is there any zinc here? No. Alkyl halide is present. Okay. So there is alkyl halide present, but zinc is there. No. This is also wrong. So third option D is magnesium and alkyl halide. So magnesium is present. Yes, and alkyl halide is also present. So it is made up of how? It is made up of magnesium and alkyl halide. So Grignard reagent is prepared by the reaction between magnesium and alkyl halide. Okay. So you get RMgX by reaction of magnesium with alkyl halide. So option D is the right answer. Understood? Okay. So we'll go for the next question. Chlorobenzene reacts with Mg in dry ether. So what is the structure of chlorobenzene? So chlorobenzene is this. So chlorobenzene, it reacts with what? It reacts with Mg in the presence of dry ether. Okay, in the presence of dry ether, it gives what? In the presence of dry ether, it will give you MgCl. Okay, it gives you a compound A. So this is a compound A. Now this will further react with what? Ethanol, CH3 CH2 OH. So here I said RMgCl. So R will be the negative part and this will be the positive part. Okay, and when you're talking about alcohol group, CH2 CH3. Okay, so this will be positive part, this will be negative part, and this will be again positive part. Now what all will get combined? Just see here. So here, whenever RMgX is there, okay, Grignard reagent is there, Grignard reagent will be preferred as base. Okay, it will behave as a base. So here how the attack will take place, just see here. So R will get combined with hydrogen. Okay, and this will get combined here like this. So this will be the product. Write the product now for this. So this will be what? So R. So this H will get combined with. Now here out of this, now this I told you, okay, which is negative part, which is positive part here. So this is what? Now this is what here? This is R. Is it R? This is R, right? So this is a negative part, right? And MgCX. So this is negative part, R is negative part, right? MgCl, this is positive part. So what is getting combined? R is getting combined with H. This is the H which will get combined. So this will get attached with here. So what will be the product? So the product will be benzene. Okay, the product will be benzene plus CH3, CH2O, MgCl. Understood? Got it? So what is our option? B. So benzene is the product obtained. Understood? See, one more time I'll tell you. I'll tell you one more time. So you can see. Okay, you can see here that R will be negative and this will be positive. When you are talking about ethanol, this is ethanol, right? CH2, CH3 will have a positive, partial positive charge. This will have negative charge. This will have positive charge. When it is getting combined, it will get combined like this. How? R will get combined with H. Okay. And this will be left with, so R will get combined. So R will get combined with H like this, and MgCl will get combined with oxygen and OCH3 like this. Now here R MgCl, right? This was MgCl. So R is what? R is this. So this will get negative part. This will be positive part. So, so this will get combined with what? This will get combined with H. HOC2H5, right? So this will have positive charge. So this will get combined here. So this will get combined with, and the other part will get combined with this. So write the answer. So this will be benzene and this will be MgClO2H5. Understood? So option B is the answer. Okay, so we'll go for the next one. I hope this is clear. Understood? Okay, so simple questions. You feel it is complicated, but they are very simple questions. Okay, so next question. Benzene reacts with N-propyl chloride in the presence of N-hydrous AlCl3. Okay, so what type of reaction it gives you? So here, benzene. So benzene reacts with N-propyl chloride. N-propyl means CH3, CH2, CH2, Cl. N-propyl chloride in the presence of AlCl3. AlCl3 is what? It is a electron deficient compound and it is a Lewis acid. Okay, it is a Lewis acid. So this CH3, Cl2. Okay, what will happen? There will be formation of carbocation here. So CH3, CH2, CH2 positive, and this Cl, okay, will attack with this. So it forms AlCl4 minus. Okay, so what will happen here? This will undergo a rearrangement. Okay, this will undergo a rearrangement. How it will undergo rearrangement? There will be shift from this hydrogen. So there will be shift in this particular hydrogen, that is CHH. So this shift will occur and it will form CH3, CH double bond, CH2. Okay, and thus this will, so this will create what? Not this positive. What will be happen? This will be your shift. There will be shift in the this. So it will be CH3, CH. Okay. So what will happen? This hydrogen will get shift and it will have, so this is primary carbocation. No, so if you shift hydrogen shift, it will have a secondary carbocation. So as compared to primary, secondary will be more stable. So there will be shift in hydrogen and this forms a secondary carbocation. Now this will attack to this benzene. Okay. And what will form? So it will form CH, CH3 and CH3. So this is what it is called as isopropyl benzene. Okay, option D, isopropyl benzene. Understood? So benzene in the presence of N-propyl chloride, in the presence of Lewis acid. Lewis acid is electron deficient compound, so it will abstract the negative this. So it forms what? AlCl4 minus. So this will form a primary carbocation. As primary carbocation is unstable, so it will try to form the, it will abstract the hydrogen from this center carbon and it will form what? Secondary carbocation. This secondary carbocation as compared to primary, it is more stable and this will attack the benzene ring and you get a isopropyl benzene. So D is the answer. Understood? So industrial preparation of chloroform employs acetone and, okay. So industrially, when industrially preparation of chloroform, it employs. So whenever you're preparing chloroform, so what is yielded? So acetone, when it reacts with calcium hypochlorite. Okay, it is calcium hypochlorite. So acetone, it reacts with calcium hypochlorite to give you CHCl3. So industrial preparation of chloroform, it employs acetone and calcium hypochlorite. Remember this, it is calcium hypochlorite. So the steps are like this. So that is calcium hypochlorite, it reacts with oxygen water to give you calcium hydroxide plus chlorine. Okay, this chlorine which is obtained, it acts as a mild oxidizing agent. Okay, as well as a chlorinating agent here. So this, thus the acetone and hypochlorite which is produced will it is used for the preparation of chloroform. Understood? So remember calcium hypochlorite. One more last question. Phosgene is a common name for A, phosphoryl chloride, B, thionyl chloride, C, carbon dioxide and phosphine, and D, carbonyl chloride. Yes. What is the common name for phosgene? Common name for phosgene. The common name for phosgene is carbonyl chloride. Okay, yes, it is carbonyl chloride. Understood? So these were some of the questions from haloalkanes and haloarenes. Okay, so I hope haloalkanes and haloarenes chapter is clear. Okay, so next, so for Thursday, I'll start with D and F block elements. Okay, so if you have any doubts, you can ask me or we'll end the session here. Okay then. Okay, thank you. We'll end the session here. Okay, we'll meet in the next class.